Okay guys, this is section 2 in chapter 6 about describing the types of chemical reactions. So when you talk about chemical reactions, much like text messaging, it's using symbols and abbreviations to say something in a shorter form. So there are different formulas. You're pretty familiar with some of them, like water, maybe carbon dioxide, probably sodium chloride or table salt. We use the shorthand, the formula way of writing things. So when you look at a chemical equation, you need to understand the parts of it. The stuff that you start off with, those are called the reactants. The arrow is actually a yields sign, meaning what does it give you with a chemical reaction. Products is what you end up with. If you have something like this Ca that's here, that's called a symbol. If you have a combination of symbols or elements, then that's a formula. And when you have a little tiny number down here at the bottom, that is actually called a subscript. The conservation of matter, this is the lab that we just did, talks about the fact that whatever you start off with as far as matter, you have to end up with. So when I start here with 14 grams of iron and I have 8 grams of sulfur and I make iron sulfide, and this yield sign represents a chemical reaction took place, then I have to end up, the matter or the mass in the object has to be the exact same. So we started off with 14 and 8 and we have to end up with 22. So there's two different types of systems when we deal with, when we talk about considering the law of conservation of matter. There's an open system and a closed system. Closed system means that no matter can get in or out of the reaction. An open system means that matter can escape from or come into the chemical reaction. So if you got a difference in the conservation of matter or mass lab, when we did that with the Alka-Seltzer and water, it's probably because you had more of an open system than a closed system, even though we tried to create a closed system with the stopper. So when you balance an equation, you're going to start off with things like maybe you have 2 hydrogens here, H2. Ignore the fact that this is a highlighted 2. And you're adding it to 2 oxygens, and you end up with 2 H2Os, meaning 2 water molecules. So in order to balance that, we've got to add a coefficient to the front of this H2. So when we count up all the atoms, we have 4 hydrogens now, 2 oxygens now. Over here on that's on the reactant side, and on the product side, we have 2 oxygens and 4 hydrogens. So there's different kinds of chemical reactions. The first one is synthesis, meaning we have many parts and we're putting them all together to make one thing. So we make one compound at the end. Decomposition, which is the opposite of synthesis, we start off with one thing and we tear it down into parts. Then there's a single and double replacement reaction. So single replacement, we start off, I know they have shapes here, so think of it as we start off with an element, a single thing here, and a compound, and we end up with an element and a compound, but it's just a different element by itself and a different compound. Double replacement, you start off with 2 compounds. So this is a compound here, this is a compound here. They end up kind of switching partners, and we still end up with 2 compounds, or just different compounds than we started off with. And that's it.